Kia ora koutou, Reese from QuickSense here, and today we're looking at box and whisker plots. Now in this question we're asked to find the median weight, and there are a couple of visual parts of the box and whisker plots that's really important. So first of all we have the whiskers. So we've got a whisker here and a whisker here, and this shows us our range. What is the minimum value? All right, that's down here. And what is the maximum value? Okay, so every single piece of data is between these two bits of information. But often that's not really important. What we care about is where do most people fit, right? Where is most of the data? Well, most of the data, the middle 50%, that's between this part and this part. It's the box. And this is what we call the lower quartile and the upper quartile. And all that means is we're splitting the data into 4 quartiles, 25%, 25%, 25%. So within this distance here, we have 25% of the data. Within this distance here, we have 25%, and so on. So if I've got 25% and 25%, well, that's 50%. And that leads us with our last visual bit of information, which is my median. Right? Where's the middle value? So what was the middle median weight lifted? The median weight is that middle line, which is equal to 51 kilograms. Now this next question is asking us to determine which of the following statements is true. So the first one is the data symmetrical? Now if the data is symmetrical, what I would expect to see, so let's have a look here. I would expect to see a box and whisker plot where there is symmetry in the lines. Right, so if these are, if this is where my my range is, then I would expect to see the middle in the middle of these two. Right, so this distance is the same, and this distance is the same, and then the same is true for the upper and lower quartile. So they could be here and here, or here and here. Wherever they are, they have to be symmetrical, the same distance from the middle. And looking at my graph, right, I can immediately see the distance from here to here and here to here is not the same. So what does that mean? That means that the data is not symmetrical. So that's false. The data is skewed to the right. And the next one is the data is skewed to the left. Now let's leave these for the moment because it is a little bit technical. What do we mean by right and left? Right, if it's not symmetrical, then it is going to be skewed in one direction if it's unimodal. So what does unimodal versus bimodal mean? Well, unimodal looks like this. Right? That suggests that there is one value, uni, which has the most. Right? The modal. It's the value with the most. Bimodal, right, has two values which have the most. Now this data here, we actually can't really tell. Right? There's no way in this data for us to determine which value happens the most. But what we can see, right? Oh, so we have no way of telling whether this is true. So we're going to say we don't know. Now the data is skewed to the right or the left. Well, let's try and draw this like we've drawn, so this is 4 here. Let's try and draw this like we've drawn the one on the bottom. So I have my lowest value is down here, my highest value is up here, and then the middle value is around here. Alright, so what does that look like? Well, if we were to plot it, we can see that the data has been pulled to the left. Right? It's like someone, because it should be, if we have a look at this, it goes down and then 1, 2, over there. So it should be around here. But someone's pulled it to the left. And that means that the data has been skewed to the left. So which one's true? Well, it's number 3. The data is skewed left.